stupid suspension doesn't work! On this episode, we're working on the front suspension of Project Beast Mode. Now, when you build a Jeep, there's a couple different ways you can do it. You can build it at ride height, or you can build it at full compression. On this Jeep, I built it at ride height because I have leaf springs in the rear, so I can't really compress those fully, so everything is built at ride height. So on the front suspension, putting it together, I put in just a spacer bar that I've welded in so I could build everything flat, get all the suspension geometry right, build the fenders flat, and so on. So now I have to build the front suspension. And to build the front suspension, I really didn't know what I was doing. So I called up the guys at TMR, and the conversation looked kind of like this. Hi, thank you for calling TMR. How can I help you today? Hi, I need to build front suspension for a 79 Jeep CJ5. Perfect. Do you know what your ride height is? I don't know. Do you know what your sprung weight is? I don't know. What kind of shock are you planning on running? I don't know. How do you plan to mount the top of the shock? Ooh. I don't know. How do you plan to mount the bottom of the shock? I don't know. Okay, I think I have the right package for you. Unfortunately, in that conversation, the really only thing I knew was how much room I had between the top of the fender well and the axle. So from that conversation, we came up with this. The challenge that we run into is space. So trying to run a full-size spring was going to be difficult. Trying to run a coilover was definitely possible. The issue that I ran into with that was I don't know what the weight of the Jeep is with the engine and everything in it. So that made it hard to be able to determine the spring rates. Sure, we could swap springs out and go back and forth trying to figure that out, but that really wasn't what I wanted to do. The other option was to go with ORIs. So when TMR recommended that we go with ORIs, they let me know some information about them that I didn't know before. So first off, these are a shock that can be adjustable as far as spring rate just based on the pressure that's put into them. It's also a bump stop, and it also works as a sway bar. I was having lots of issues with putting a sway bar on this Jeep because of the aftermarket frame. Every sway bar I got wouldn't fit. So this is going to save a whole bunch of issues, and it's going to be all in one package. The other challenge that I ran into was trying to mount them. So I know that I want to do a shock hoop of some sort, but I don't know what the height of the shock hoop is going to be, the pitch, and all that information. I just didn't have really any idea. And I also know I wanted to connect the two sides together because all the weight of that front suspension for the engine and everything else is going to be held up by those shock hoops. So they're going to have a tendency to try and pitch in. So I wanted to have a cross brace that went between the two. So this is what TMR came up with, and this is what they recommended. The kit that they recommended is a hoop kit, but it comes with extensions. So these will slide on to the hoops so I can get any range of length that I need. They come with the top brackets, and they also come with a crossover bar and the disconnect mounts for the crossover bar. So that gives me the attachment points for the top, the crossover that I needed, all in one kit. So it really saved me a lot of hassle trying to figure out how to piece it together. The second part they gave me was the lower mounts for the axle. So these will weld onto the axle. They just asked me what my axle tube diameter was, and I'm able to get those. So I got everything at a one-stop shop to make my life a whole lot easier. Here's what we're going to end up with. The ORI mounted. It is bolted through the lower brackets that are welded to the top of the axle, mounted to the hoop that is welded to horizontal tubes that are welded to plates that are bolted to the frame. And the reason that I bolted it to the frame is because when the fender comes off, the hoop is going to have to come off with it because we're going to have a crossbar going through the fender. So the crossbar is going to go through the fender. I'm going to weld it to the fender. So when I take the fender and the hoop is going to come off at the same time. So it's all going to actually be one unit. Putting this side together is the easy side because I don't have anything to really go off of. I just made it up as I went. So what I ended up with is 15-degree taper here. The strut is at a 12 degree, and it's vertical, straight up and down. So now I just have to match this on the other side. Let me show you how I did it. Step one of getting this install started, I got to make the plates that mount to the frame. Drill and tap the holes on both so I can weld the center bungs on. Putting this plate on, I'm going to go 7 inches off of my bumper bracket, because that's where the other side is. The idea here is to tap out the frame. We're going to tap the frame to put those plates on, held in by bolts. We're going to use a 3/8/16 bolt to hold it on. So I'm going to tap it out with an 1/8 inch bit, follow it up with a 5/16 drill bit, and then we're going to run the tap through it. I wouldn't normally do this on a standard frame, but this isn't a standard frame. This is an aftermarket frame. So it's quite a bit thicker than a normal frame would be. So that's why I feel comfortable doing it on this particular project. If you've not run a tap before, there's a little bit of finesse to it. Basically, a tap is going to cut threads into the frame so I can thread a bolt directly into it instead of using a nut zerk or a nut on the back. So this is actually going to cut threads directly into the frame. The most critical part is when you're starting, you want to make sure you get it in there straight. And once you get a good bite on it, we're going to back it off a little bit to clean out the threads. We're going to go a little bit, back off, go a little bit, back off. So as we cut the threads, we're going to break them loose, and that way all that chips and everything can get out. It might be a little bit overkill, but after I get done tapping it, I like to run a thread chaser through it. So when you run a tap through it, it actually cuts the threads. But in doing so, it also leaves a lot of sharp edges and sharp points. When I run a thread chaser through it, that's going to round everything off and clean up those sharp edges. What I found is if you try and run a bolt straight through on a tap, it'll go in fine, but then sometimes if you have to take it back out, it'll have trouble. So this will smooth it out. Now it's time to cut the nub that sticks out. Now that I have the nubs on, it's time to put the hoops on. When I got this TMR hoop, it had extension pieces that came with it. I wasn't for sure how long the hoops were going to be when I put them in, so I went ahead and ordered those at the same time. Fortunately enough, on this one, I'm not going to need it. When I put the hoop on the other side, I leaned it back at a 15-degree angle, and it actually has a tilt to it out towards the outside of the Jeep of 15 degrees also. So now I have to match that. So to do that, I got to figure out where my first cut is going to be with the hole saw to get these two pipes to match up. This is just a cheap tubing notcher that I got from Harbor Freight, and it's done me well so far. You just got to make sure that you keep it lubricated. On the drill, I had to get one of the professional grade heavier duty drills. I went through quite a few of the Harbor Freight drills and just burnt the motors up pretty quick. On the jig, I have it set at 15 degrees to get my lean, and I need to set it flat so I'm on the same plane. So to do that, I'm going to use a straight edge and an angle finder just to make sure that I'm on a level plane. One of the downsides about this is the hole saw is not deep enough to cut all the way through the pipe if you're at an angle. So I'm going to have to cut off some of that pipe to be able to finish the notch. Or you can break it off. And this is where it takes a little bit of finesse, practice, going back and forth. On the hole saw, I cut it a little long because I wasn't for sure exactly where I needed to be, because trying to take measurements to try and get the height correct is very difficult. So basically, when I notched it long, because I can always take off more if I need to. What I want to do is I'll put my angle finder on there, get my 15 degrees, which is there, and then measure from the top to here. So I want to have 1.5 inches, and right now I have 0. So I'm going to go back over the notcher, notch that out some more, and come back. So before I got too far out of control, I went ahead and rechecked the other side, and I was incorrect. This is supposed to be 30 degrees, and it leans out 15 degrees. So I'm glad I double checked that, because if I was trying to get to 15 degrees, I would have cut this way too short. So now what I'm going to do is position that where it needs to be, mark out where my rear plate needs to go, and then get the rear plate put on. Same way as I did the front. Back here is where my tube comes down, and I need to put my plate there. But as you can see, there are holes that are already drilled in the frame. These holes are there from the factory also, and some kits will use those to locate motor mounts. They're not going to be used in this particular application, but when I put the bolt holes in, they're going to be awful close to those holes. So actually I'm going to fill in the 2 center holes here with weld. Now, the guy that I got the frame from decided it was a great idea to use this rubberized undercoating crap. Not a big fan. So I'm going to scrape off that rubberized undercoating and clean that up real good with the brush and weld it in. I got the back plate bolted on after I drilled and tapped the holes, got it all in there secure. Now's where we're going to do a little bit of a dance, because I got to lay this on. I guesstimated about where the knot should be to put my back stub on. So we're going to run this down to where the stub should be. Get my right angle going. Once you get all that set up to where it's supposed to be, you can tag it in. Magnifique! So something I learned while doing the other side, the more you weld it in place, the less it's going to mess up and twist on you. The other side, I just tacked it and welded on the bench. By the time I got it put back on the truck, it had shrunk, and so I had to stretch everything back out to get all the bolts lined up. So weld as much as you can on the vehicle and just let it cool right there. That way it doesn't shrink and manipulate too much on you. Now we're going to put the brackets on the axle. Now I know it's hard to believe that I have ever made a mistake, but whenever I ordered these, I didn't think about ordering the spacer to represent this space for the bracket. So when you're ordering your parts, remember to order the spacer from TMR. So what I want to do is I want to take the measurement of what that is. So I got 1.62 that I need to make up between that gap. What I came up with was this. That is a sleeve for a shock and 2 washers. And when I put those all together, they gave me a space of 1.65, which is just a little over, which is perfect. That's exactly where I want to be. So I'll take just a random bolt I have laying around that's the correct size. On, washer, sleeve, washer, bracket, knut, and I have 165, 166. So that'll be perfect for what I need to do. When you're putting these on, make sure you don't put the bolt against the spindle, because once you get it all welded and you try to take that off, you can't get your bolt out. So you got to think about that before you weld it down. In order to make sure that I get these at the same angle, put the angle finder on that one, put the angle finder on this one, and make sure they match. That side was at 10 degrees, so I'm going to make sure this one is at 10 degrees also. It's time to get the ORI mounted to the top of the hoop. I'm going to use the brackets that came with the kit from TMR and just bolt them through and then tack it. To be able to extend the ORI, easiest way is to take the Schrader valve out of the top here, and that way it'll extend a lot easier. There are a tremendous amount of factors that you got to take into consideration when you're putting these on. One of those is the length that is exposed on the shaft. They recommend anywhere between 4.5 and 5 inches. I'm set right at 5 inches, so I want to have my length set, I want to have my angle right, I want to match the hoop on the other side. One of the challenges I'm running into is getting that grind just right on that top mount. I'm going to cheat just a little bit. How I'm going to do that is I'm going to tack one side on and then just keep grinding the other side until it fits. Best way I can figure out. After a little cutting and a whole bunch of grinding, I got that bracket to where I need it to be. I'm not going to fully weld this in with the strut in place because that would just ruin it, getting sparks and spatter on it. What I am going to do is I'm going to tack it on there first. I'll put my spacer in and then finish welding it. Just like I said before, you want to make sure that you weld as much of it as you can in place. On the other side, I welded this on the bench and it pulled the whole U together, so I had to stretch it back out to be able to bolt it on the frame. So I'm going to let that cool down, that way it stays its shape. I don't have to worry about trying to stretch it to pull it back together. While that's cooling down, I'm going to go ahead and cut the circles to fill these plugs. I'm just going to use a piece of scrap steel and a piece of scrap pipe, trace around, and use my plasma cutter to plasma cut those two out. These don't have to be a perfect circle. I just need to make sure that they fit inside the plug. I'll use one of my magnets to make sure it's flush to the front of my plug and tack it in around the circle. Once I have it tacked in, I'll finish welding the rest of the plug in, making sure not to put too much heat in one spot. I'm going to jump around a little bit to be able to dissipate that heat, maybe go back and forth between the two plugs. Once I have those two plugs welded, it's ready to clean them up. I'll use a 4-inch flat disc on my grinder to clean up all the welds and make it look pretty. And it's in! I'm a long way from done, but I do have the caps put in, all the welding is done. I just got to finish bolting it to the frame, but the biggest thing I have to do yet is the crossover between the two, because all the weight of the Jeep is up here now, which is going to try and twist those in anytime it can. So I'm going to put a crossover bar that pops out. That came with the TMR kit, so it's going to be an easy fit. I just have to do some little tweaking here and there, a lot of welding. So stay tuned, check it out on part 2.